In this video, we're going to go through a few examples exploring the law of multiple proportions. In the previous video, we stated that the law of multiple proportions states that if two elements A and B form different compounds, the ratio of the masses of A and B that combine with one another will be different, but in each case, the ratios will reduce to multiples of small whole numbers. We then gave an example comparing water to hydrogen peroxide. I'm now going to go through and show how that example supports the law of multiple proportions. Hydrogen peroxide contains one atom of hydrogen for every atom of oxygen in the molecule. This is because the molecular formula for hydrogen peroxide is H2O2. The mass ratio of hydrogen peroxide is therefore going to equal the mass of one hydrogen to the mass of one oxygen. This equals 1 to 16, or 1 gram to 16 grams of hydrogen to oxygen. Water contains 2 atoms of hydrogen for every atom of oxygen, for a molecular formula of H2O. Its mass ratio is therefore 2 times the mass of hydrogen to every 1 times the mass of oxygen. This equals 2 to 16, which reduces to 1 to 8. Let's say we have a compound that for every atom of A, we have 2 atoms of B, so a compound AB2. 1 gram of AB2 decomposes into 0.273 grams of A and 0.727 grams of B. We're trying to find out what the formula of a second compound of A and B is that will decompose into 0.429 grams of A and 0.571 grams of B. Going through our problem-solving strategy, what we're being asked to solve is the formula of that second compound made of A and B. The pieces of information that we're given or that we know is that 1 gram of AB2 yields 0.273 grams of A and 0.727 grams of B, that the unknown compound AXBY yields 0.429 grams of A and 0.571 grams of B, and we know that the law of multiple proportions must hold. In this problem, we're going to employ the same strategy we've been using in the past. Starting from the answer we want, we're going to determine knowns and unknowns until we only have knowns, and then work our way forwards. What we're looking to solve is the coefficients of x and y in the molecular formula AXBY. We know that the law of multiple proportions must hold. Therefore, x and y must be whole numbers. The ratio of the mass of 1 unit of A times x over the coefficient x to the mass of 1 unit of B times y over the coefficient y should equal the mass of 1 unit of A to the mass of 1 unit of B. We have the masses of A times x to mass of B times y. We just need to determine the coefficients x and y. We can determine the ratio of 1 mass A to 1 mass B from the information given about the AB2 compound. The mass resulting from decomposition of A to the mass resulting from the decomposition of B divided by 2 will equal the ratio of the mass of 1 unit of A to the mass of 1 unit of B. We can use that information to then solve for the coefficients x and y. We're now going to implement our strategy using the information given in the problem. Starting with the decomposition masses obtained for the AB2 compound, we have 0.273 over 1 for A, 0.727 over 2 for B. To give a 1 to something ratio, we're going to divide by the mass of A. This yields a ratio of 1 to 1.34, which is easier to work with. Plugging in the masses obtained from the decomposition of the unknown AB compound, dividing by the coefficients, we know that this has to come out to be 1 to 1.34. Going through, dividing through by the mass of A to bring it to a 1 to something ratio. We get a 1 over x to 1.34 over y ratio. Therefore, x and y have to equal 1, and the molecular formula for the unknown has to be AB. Going through and estimating if AB is a correct answer, we're going to make some assumptions. In the AB2 compound, we're going to round the mass of A up to 0.3 grams, and we're going to round the mass of B down to 0.8 grams. Because there's 2B for every A, we need to divide that 0.8 by 2, yielding 0.4. A 0.3 to 0.4 ratio is approximately 1 to 1.3. If we estimate the amount of A in the second compound is 0.4 grams, and the amount of B is 0.6 grams, that ratio of 0.4 to 0.6 is 1 to 1.5. Those two ratios are similar, indicating that AB is likely the correct formula. In the next video, we will be discussing the discovery of the electron.